If you've ever wondered why, when you get into a vehicle, the metal car seat buckle feels a lot hotter than the seats, or if you are out by the pool on a hot summer day, the water in the pool feels a lot colder than the concrete around it. Both of these occur due to a property that we call specific heat. And specific heat tells us that every substance has its own ability to absorb heat. So this is a physical property that will be unique to each particular substance. Specific heat is defined as the amount of heat needed to raise the temperature of exactly 1 gram of a substance by exactly 1 degree Celsius. And if we take a look at the table and the values in this table, notice that the specific heat of concrete is 0.88 joules per gram per degree Celsius, and we'll see where these units come from in just a moment. Whereas the specific heat of water is 4.184. So the specific heat of water is a lot higher than the specific heat of concrete, which means that water can absorb a lot more heat before it changes temperature. And this is why it takes a lot more energy for water to heat up than it does for concrete or various metals to heat up. Okay, let's take a look at where the units come from on specific heat. And it'll be really helpful to keep in mind the definition of specific heat when we're looking at the units. So notice that it's measuring the amount of heat to raise the temperature by exactly 1 degree Celsius. So if we turn that definition into an equation, I'm using the letters SH to represent specific heat here. We're really saying how much heat is being absorbed to raise the mass of a substance by some temperature. And heat is expressed in joules or calories, depending on which unit you prefer to use for heat. So we can actually write this up as 2 different equations. We'll use joules in one and calories in another. So it'll be the heat needed to raise the temperature of 1 gram of substance by 1 degree Celsius. And here I'm not including the numbers because the numbers are just 1. So that's where that compounded unit comes from. It's joules per gram per degree Celsius. And that's why the units of specific heat look a little bit funky. I recommend writing them in this particular format. So don't use the slash, because when you put that into an equation, it becomes really difficult to see which units cancel out. So I prefer to have a very distinct numerator and denominator so I can see how everything cancels. Now we can express heat in calories instead. And in that case, it would just be a calorie over gram over degree Celsius. So you can express specific heat in either or, and usually tables will give you values for each unit, and which unit you select really depends on which unit the problem is asking you to work in. So you could use either joules or calories. One thing I should note is that this little symbol delta here means change in. So this is saying change in temperature. Okay, now we can actually rearrange this equation to solve for heat. And in order to do that, I'm just going to change the variables a little bit because this equation usually comes in a slightly different format. So here I represented specific heat as SH. That is often represented as just the letter C. So both of these mean specific heat. The variable for heat is typically Q. Mass is represented by M, and the change in temperature is represented as delta T. So I'm going to rewrite the specific heat equation from above using these units. So that would be C is equal to Q divided by M and delta T. Now, if we wanted to solve for heat, or Q, we can rearrange this equation. So if I want to have Q off by itself, I'm going to multiply both sides by M and delta T. And then here, M and delta T will cancel out. And what I will get is M times delta T times C is equal to Q. So this is a very, very common format that this equation appears in. Q is equal to the mass, or Q, or which is heat, is equal to M, which is mass, times delta T, which is the change in temperature, times C, which is specific heat. So I usually provide this formula to my students. It's not something that needs to be memorized. You would just need to be able to use it. But notice that this really just comes from the definition of specific heat, which is where these units came from. Okay, let's try a practice problem using this information. So this is asking us to calculate the heat in kilojoules needed to heat 75 grams of water from 23 degrees Celsius to 78 degrees Celsius. Now it's asking us to calculate heat, and the variable for heat is Q, which means this is the form of the equation that we want because we're trying to solve for Q. So this is set up really nicely where we just need to plug in the values and we're going to be left with heat. The unit is in kilojoules, which means that when I look up the specific heat of water, I'm going to look up the value that's expressed in joules, not in calories. You could do either or, but if you were to use calories, then you would need to convert to joules first, so it's easier to just use the specific heat that's already expressed in joules. Now, it's asking for 75 grams of water. Grams are a unit of mass, so that's my M variable right here. I'm trying to find Q. C is specific heat. That is something that I would just look up in a table. And in that table we looked at earlier, we did have the specific heat of water, which was 4.184 joules per gram per degree Celsius. So I'll just copy that over on the next page. So the specific heat of water was 4.184 joules over gram over degrees Celsius. And notice that I'm writing it in this type of format where there's a very clear line. I can see the numerator and the denominator. And then you'll see once we plug this in, it'll make things really easy to cancel. The other piece of information I need is the change in temperature. That's not given to me explicitly, but I'm given the starting temperature, or T initial, which is 23 degrees Celsius, and the final temperature is 78 degrees Celsius. Well, to get the change in temperature, I'm just going to subtract the initial temperature from the final temperature. And that will be 78 degrees Celsius minus 23 degrees Celsius. And then now that I have all of these values, all I have to do is plug them into the equation. Okay, so Q is going to be equal to the mass, which is 75 grams, times the change in temperature, which was 55 degrees Celsius, times the specific heat. And the specific heat is 4.184 joules divided by grams divided by degrees Celsius. And here you can see why it's so important to have a very distinct line that shows you what is in the numerator and what is in the denominator. Because now we can see that we have grams on top and grams on the bottom, so grams will cancel out. So those are gone. We also have degrees Celsius on the top and degrees Celsius on the bottom, so those will cancel out. And that means that the unit that we are left with is joules. And that's what we want because we're trying to calculate heat. So the unit should be joules or calories if the problem asked for calories. Now we will need to convert to kilojoules at the end, but I'm going to solve for this first. Or alternatively, you could just add another step here and convert to kilojoules immediately. So I'm going to get a very large number. I'll round at the end. And I need to convert that to kilojoules because the problem is asking for kilojoules. So I'm going to add another step here. There are 1,000 joules in a kilojoule. And since here joules are on the top, I need to put joules on the bottom in order for those to cancel out. So 1,000 joules go in the denominator and 1 kilojoule in the numerator. And now joules cancel out and our answer is left in kilojoules, which really means you are dividing by 1,000. So the final value here will be 17.3 kilojoules. And that is quite a bit of heat that is needed to increase the temperature of water by 55 degrees Celsius, which is why it takes so long for water to heat up. Okay, so that's a very common type of problem that you could see where you are given specific heat, you're given temperatures and mass, and you need to calculate Q, which is heat. There is another version of this problem that you could see, which is going to give you information and ask you to find the identity of a substance. So specific heat is a physical property, which means you can use it to identify substances. This problem says that 73.46 joules, well, joules are a unit of heat, so this is heat, or variable Q, were needed to heat a 5.3 gram sample, well, that looks like a unit of mass, of a metal from 17 degrees Celsius, that looks like a starting temperature, to 53 degrees Celsius. That looks like a final temperature. And it's asking us to find the identity of the metal. Well, that looks a lot like our Q equals mc delta T equation, but here we are given Q, we're given M, and we're given delta T. We just need to subtract a couple of values. So really what we're being asked to find is specific heat. And once we know specific heat, we can look up the values of different metals in a chart and see which one matches. Okay, well, we're trying to solve for C, which means we need to get it by itself. So I'm going to divide both sides of this equation by M and delta T so that those can cancel out. So on this side of the equation, they cancel, and we are left with C is equal to Q divided by M delta T. Now I'm going to calculate the change in temperature. So this is, the final temperature is 53 degrees Celsius, and the starting temperature is 17 degrees Celsius. So I'm going to subtract those two values, and that gives me 36 degrees Celsius. The heat is 73.46 joules. The mass is 5.3 grams, and we just calculated the change in temperature. So I'm going to divide that. So 73.46 divided by 5.3 times 36. And that's giving me a value of 0.385. And here you want to be careful with the units. Notice that nothing here canceled. Up top we have joules, in the denominator we have grams and degrees Celsius. There's nothing canceling here. And that's okay, because that matches what the unit of specific heat should be. So it should be joules over grams over degrees Celsius, or calories if you were working in calories instead. So now that I have the value for the specific heat, I'm going to look that up in the table and see, well, which metal does it match? And it looks like the 0.385 matches copper. And notice that our units are also correct. Everything seems to match here. So the metal that we are looking for is copper.